So one of the things that's interesting about cloud computing in particular is that you get access to a bunch of capabilities that you normally wouldn't have access to. So in AWS, for example, you're going to get CPU, you're going to get storage access that is essentially infinite. And then also you have these APIs that they're constantly developing that are building, higher and higher level capabilities. So in the case of a computer vision API, what's happening is behind the scenes, they're adding new capabilities for labeling the images. They're adding new capabilities for detecting objects. And you as the user, all you need to do is provision a cloud-based development environment. And in this cloud and development environment, you can access all of these capabilities. So you can access, essentially infinite storage. You can access infinite disk I/O. You can access infinite, even in a way, resources or capabilities, because you know that at least until AWS goes out of business or something like that, they're constantly going to be updating and adding new capabilities behind the scenes. And in the case of computer vision in particular, this is really powerful because they're going to get very, very good models that you can use yourself in building solutions. And so what would one of those solutions look like? And this is what we're going to build today. In general, what I like is to think about building things as a function in Python. And in particular, why I think a function is important is that you can create a command line interface. You can also create a serverless function. And you could also build a web app. You could also build a script. And you also could maybe give that to somebody else and they could build a library. And that's what's really powerful about a function in a cloud environment, is you have so many different capabilities of how you can build things. And so in our case, we'll start off with a command line tool, and then we'll convert that into a little bit more of a powerful framework, because we'll use the serverless technology to expand it. So that's what I'm going to do next year is go through and build out a AWS environment. So I'm going to start out with AWS console here. Go here. And with the AWS console, I'll log in and go here. Probably have to type in my auth code. So let's go ahead and do that. And we'll say all right. And then from here, I'm going to use a service called AWS Cloud 9. There we go. Let's type in Cloud 9. There we go. So this is an IDE for writing, running, and debugging code. And what's great about this environment is that it really does give you these capabilities to natively interact with cloud computing here. Let me just throw you guys here. And what's fun about this is that it really simplifies a lot of the things that are a problem in terms of cloud computing, in that you don't have to install software, you don't have to configure things. It's all ready for you automatically. So let's go ahead and do this. We'll build let's say a computer vision demo environment here, and this is an environment for demos. There we go. And go to the next step here. Now, when we set this up, a couple things to keep in mind are that the actual environment itself will be launching a new virtual machine. And so this new virtual machine will be something that can be free. So if you use the T2 micro instances, for example, and you're using the free tier, the free tier is actually great for building APIs. And in fact, you could use this essentially forever for free because it's so inexpensive and cost effective. That's why I really enjoy using it. But at the same time, if you did need to use some, let's say you were working on a project where you needed to do some parallel computing with maybe a high performance computing library, plus you wanted to talk to a computer vision API, you could do both. And you could actually go through here and pick another instance and let's say grab, I don't know, a 128 gigs of RAM machine, or grab a machine that's got a pure metal machine that's got 96 cores and 200 gigs of RAM. So you can have a lot of options. And in addition, what's nice about this is it uses the default environment that you would expect on any server in AWS. So Amazon Linux is a great environment to test things out, and you can use that environment inside of this Cloud9 environment. Also, this cost savings setting here is really critical because this allows you to, just like if the air conditioner in your house, for example, if you leave it on in the summer, it can be very expensive. But ideally, you want to have it automatically turn off. And with this turns off after 30 minutes. And then you're only billed, I think, by the minute or by the second. I think it's by the second. So really, this is extremely cost-effective way to do programming. It's essentially free. And as I mentioned before, the advantages of this is that you don't have to worry about installing software and getting your environment correct. And this is often one of the biggest problems with doing any kind of software development is your local development environment is really a hazardous location. It's like a bad part of town where you don't know what's installed. Something could happen to your machine. But with this, because you're working in the cloud, you can just, in fact, your internet connection could go down, and then you could reconnect to it, and everything's there. So really, it's an ideal scenario for building software. So I actually mostly build software now using these cloud-based environments because they're just so simple to set up, and they solve many problems for me. So this takes just a second here to build this up. Okay, so the first thing that I would do when I'm using a Cloud9 environment, and let me just show you a couple of things that you can get here, is that just to maybe do a tour, is you can go through here and say AWS S3, for example, and this command, I think if help will work. Let's see, S3 help, does that work? It will show you all of the different things that you can do just from the command line. So you can move files, copy files, which is really common when you're working with the cloud. And because you're in the network, the copy is very fast. And this is another thing that really is a problem for many people, is that they're working with data that's off of the cloud, and then you have to copy the data back and forth. But if you have the data living in the cloud and you use these cloud-based environments, especially computer vision is a perfect example, you can actually get extremely fast operations. So again, if I typed in AWS S3 LS, for example, I can see all the buckets that I have. Or if I want to copy stuff, I can sync it, and I can even do deltas as well. I can do like differential copies. So that's really the lay of the land. And typically, what I would do to start with is I would create a virtual environment so that I could isolate my Python environment to a particular directory. That way, if I check out multiple projects on here, I can go back and forth between them. So I'm going to go ahead and do that. I'll say python 3-mvenv, and I'll say, CV demo, just like that. And next, what I will do is source that virtual environment. So we'll go through here, CV demo, ban activate. And what this does is, you can see it shows me that I have a Python that's in this directory. And that way, again, I can toggle back and forth on projects. And then the next thing that I would do would be that I would go through here and set up a new repo. So let's go ahead and do that. We'll check in a repo. We'll call this CV demo AWS. Here we go. This is a new repo for demoing computer vision. And then I typically will add a README file and a getignore file. And then the getignore file, I'll use Python, since it will ignore just like irritating files that I don't want to be checked in, like a .pyc file, for example. Okay, now that I've got that created, I can actually just go through here and just give you this, since I'm going to be checking in some stuff. And let's see here. Well, anyway, you can get to it. There you go. No gift CV demo AWS, and then I'll just click on this link and try to download it. And I'll go here and just do git clone like that, and we'll go through. Now notice that I can't check it out because I need to put my SSH keys inside of GitHub so that I can do encrypted bidirectional communication back and forth. So this is only a one-time setup. So if you've never used this environment to talk to GitHub, you only have to do this once. And so what I typically would do SSH keygen -t RSA like this. There we go. So create my SSH keys. I press return like 5 times, and this just creates a public and private key. And then I can copy this. Let's go ahead and do this. Let's cat this file out, and then I'll paste this into my repo here. So we'll go through here, and then I can just go to this location and go to settings and put them under SSH and GPG keys. There we go. New SSH and GPG key. Paste this in here and just say, new key. There we go. All right. Okay, so once this key is set up, I can go back again to this repo and just go through here and do git clone. There we go. Now the git clone works. So I've got a pretty good setup here. I got the virtual environment. I got Python set up. And now how do I actually start building out software? The first thing I would recommend is scaffold out a structure. So I would cd into this demo directory here, and I would create a make file, a requirements file, and then I would also create just like a hello script. So I would go through here and say make file, and then I'll go through here and do a requirements.txt file. That will list all the packages that I use in my project, and then I'll just make like let's do something like object detection. So we'll say hello object, or hello obj.py. There we go. And then what happens is I can actually go to this directory and just start populating these. So what I would do, since I already have a bunch of these things created previously, I'll go to the edge-based computer vision project and just kind of grab some ideas here. So I can grab this. I can grab some of the stuff I did before, just throw this in there. So go here and do that. So go to this make file. Now, one thing to keep in mind in these cloud environments is that a lot of times the make file itself will need to be converted to tab format. So if we see here, we can see it's converted to tab format. And this is something that'll just cause errors that'll be irritating. And I can just get rid of stuff I don't care about. Like I already created a virtual environment. I don't need that. I do like to do this when I create a new project, in that it always installs the update of the Python package tool, which is pip. And then I can maybe get rid of this. I don't really need this for now. And then I like to lint things because what this does is just check for the syntax so that I don't have syntax errors when I'm writing code. And we'll say here, we'll just say hello obj. We'll say hello or hello bj. There we go. And that looks good. All right, so now that I got that set up, that looks good. I can actually go to a requirements file and add a few libraries that I might think would be helpful. So Bodo3 is one, and we'll get into this in a second. That's a library for doing installations for talking to AWS via their SDK. And there's a ton of different resources you can talk to. We're going to use the computer vision resource. And then I'll also install Click, which is a command line tool. So I think, and then also install PyLint. So now that I've got those, how do I install them? Remember here, I created this installation command in make. And this is just something I do in all my projects because I like to type as little code as possible. And so if I go here, I can say make install, right? It runs this block and then it installs all my software. So this is a good little trick to just be aware of in projects. Okay, that looks like it's working. And now here's where we get into, writing a function. And I was saying before, a function really is for a lot of things you're doing in Python is good enough. And I'm going to go to this thing here. I'm going to say maybe like import Bodo3. Let's create this thing. And then let's say, I don't know, how about detect labels? Or yeah, we'll call it detect labels, and we'll give it, I think we would have to pass in a image file name and a bucket name. So we'll say, and a bucket is a location in S3 where you can put data. It's like object storage. So I'll say bucket and image. And to start with, just to make it really, really simple, I'll just print these out so that I can get something working and just say this is the bucket, like this. And this will just essentially get like the scaffolding of the script that I'm going to write working. So we'll go through here, say this is the bucket and this is the image. There we go. And so I'm using this f-string format, which can substitute those curly brackets with a variable. And then that's good enough for now. So I'll go through here and I will say detect labels. We'll just we'll just do this. We'll just say detect labels, and I'll just say, bucket test, and then I'll say image test. And if I run this, in theory, this should just print out what I passed into it, right? So if I go through here and I say Python, hello, this is bucket test, and this is image test, right? So it does nothing, but what I'm going to do is I'm going to also make it into more of a script. And so how do I make it into more of a script? Well, what I can do is I can add something called a shebang line. And if I do the pound exclamation point / user bin env Python, what this means is that when you run this script, it knows to automatically look at Python as long as it's executable. So it makes it even simpler to run it. And if I go to chmod plus x and then I put that in, so this makes the script executable, all I have to do now is do this, right? I can say / and then it runs it, which is a really handy trick to know when you're building command line tools. Because in general, like, why type commands if you don't have to? There you go. So now it works. So we're in pretty good shape, but let's lint it now. Let's just make sure that we have a lint process working. So if I say make lint, and again, let me show you what that does. This just runs it through some commands that show me whether it's got errors, essentially. And if I run make lint, what does it give me back? Let's see if it works. Unused import Boto3. So it actually did find a bug. And this is a great example of the kind of bugs that it'll find, is that, why would you be checking in code that you don't need, right? It's a good way to get yourself in big trouble, because if you import enough libraries, maybe somebody else uses your code and they don't know what's going on, right? Like maybe you imported 40 libraries and it turns out that you only use one, and then someone thinks that there's a bunch of stuff happening that isn't happening, right? So this is just an idea of it still works, but it's a bad idea to import something you don't use. So maybe for now, I'll just comment this out like this, and I'll run it again, and we'll go from there. So go through here. Okay, linting works. So I'm going to now check this code in. I'm going to say get status, go here, add the make file, add this file, add requirements, and then I'm going to do a commit, and it's going to complain that I need to set up a couple things, which I'll set up real quick. So adding initial code. Okay, so notice how it says this stuff, which is, again, the first time you set up a repo, it'll ask for you to put these configuration items in here. And you don't have to do them, but I would recommend you do them so that you get a history of your project, so you know who's checking in the code, and you can keep track of commits and commit history, and it's a good idea. So we'll go through here. I'll put in my information. Here we go. All right, so now that we got this going, I'm going to reset this here. Perfect. I'm going to write this out, exit. There we go. So now I can push this. Perfect. So really we're in great shape. And let me show you, if I go back here, let me just throw this somewhere else. That's irritating. Okay, so if I go back here, I can look at GitHub and see what's happening. So let's see here. So I created computer vision something. Let's see. What did I call this thing? Computer Git. If you ever forget what you called a repo, you can just say git remote -v, and it'll tell you CV demos. So I can just remember that's the name of the repo, CV demos. So I can just do this. There you go, CV demos. Okay, so I've got initial structure. This is pretty good, but there's a few things that we could do to improve it that will dramatically make things better. And one thing is that GitHub is made by Microsoft now, or now they own it. And Microsoft really is doing some incredible things with developer tools in particular. Visual Studio Code is an incredible tool. They also have this thing called GitHub Actions here, which is awesome, because what it does is it allows you to test your code and lint it automatically, or even deploy it automatically. So I'm going to click on set up a workflow here, and notice it says a bunch of things like it can build artifacts, it can download things, but I would just say this is a good idea. Just any project you're working on, if you're using GitHub, you might as well use GitHub Actions. It's kind of a no-brainer. So I'm going to go back to an example actions that I have set up somewhere. Let's go to PyTest example. Here we go. Got an example here, and I'm going to grab one that I built earlier, and I'll explain what it does. So it really is pretty straightforward. You just tell it a list of commands, and then those commands run. So what I could do is I could format my code, I could test my code, I could lint my code, right? These are all the different things that it can do. So maybe I'll take the test out for now, since we don't have any testing, but I do like the formatting. I think the formatting is a pretty good idea because it can make it so that our code looks a little cleaner and makes it look more professional. So I'm going to show you how to do that in a second. So I'm going to change the order because I think it's probably better to format the code after installation and then make sure that the, no, actually, let me think about it. Lint. No, I like this order. Never mind. I'm changing my mind. So yeah, we lint the code, make sure it even works. If it does work, then this will check to make sure the formatting works. So I think this is good setup. So it just runs these make commands for us, and I can actually run it in more than one version of Python or just run it in Python 3.8, which is the latest version. I'm going to say, go ahead and do this, run it inside of that. And then what will happen is if I go to actions here, it will actually run a build process. And a build process is essentially a container that runs commands for us. So we're basically building a little robot that goes through and tests our code automatically, which, again, as I mentioned, is a no-brainer. I think you should always do this. Here we go. You can see all of the different things that are happening here. We install the dependencies. And in fact, one thing that's neat here is, look, we see that one of the things failed. And why did it fail? Well, we didn't do it. We don't have a make format. That's why. So let's fix that. Right. So I'm going to go back to this environment and I'm going to fix this. So to do that, I'm going to go to my requirements file and I'm going to add this section here, which is a tool called Black, which is a formatting tool. And now if I say make install, that will install that tool. And then I can go back to the make file and I can add a Black tool. So we'll just say format and we'll say black *.py. So basically anything that it finds, automatically format it. And I'll show you why it's pretty cool. So if I say make format here, look what it'll do is it formatted it, found that file, and it reformatted it. And look what it did. It just cleans it up a little bit. If it finds like single quotes and double quotes, it'll make them all the same. If it finds like the spacing's off, it just makes your code look like a professional wrote it, which is a very good idea for portfolio projects. I would say there's no penalty to run this. So it's a very, very good idea to run this. So again, here's an example of what it did. Look, if I put the space there, I take it away and I run it again. I say make format. Look, see, it just kind of cleans it up and adds a bunch of rules to your code to make it look prettier. So, okay, good. We got that working. So let me do get status and we see what changed here. Here we go. Okay, so we changed a few files. I can say get add star, get commit, and say adding formatting. Okay. Wait, get pull, get push. Okay. I think we got everything here. Get pull. Or did I not commit? I didn't commit. I added one extra M here. There we go. There we go. There's push. So if I go back here to this and I go to actions, we can see that in fact this build process is cranking. There we go. Installing dependencies, linting with PyLint, formatting the code. There we go. We got everything working. So I think what I just showed you is really good for most projects, like especially a cloud-based project. But it doesn't do anything yet, right? We've only built the framework. So now let's actually make it do something. So to make it do something, first let me switch gears here and show you that the console in AWS is a great way to explore advanced capabilities. And I'm going to go to this recognition service. And what it does is it allows you to search and analyze images. And what's great about it is that I can just do it in my browser. So I can do object and scene detection, image moderation, facial analysis, celebrity recognition, text and images. So like maybe the text and images could be kind of a cool one. So if we just look for, I don't know, license plates or something like that, let's find one. If you can see here, here we go. There's a license plate right there. So I'm gonna grab this guy. I'm gonna save it on my desktop, and let's see if we can grab it. So we'll say license California, and then I go back to this console, and I can just say upload. Oh, I guess you can put a URL, so I could have done that. And then let's go to license California. There we go. And I'll say okay. And look, it was able to recognize, in this case, the objects, but which is helpful. It says vehicle, transportation, and then also we can do text and image, and I could just do the same thing. So I could actually, I think I can just grab this URL. Let's try that. Let's say copy image address, and let's just throw that in there. There we go. And if it's got a problem, it's not a big deal. I'll just upload the image again. There we go, license. There we go. Okay, so California, it looks like it got the whole license. I don't know what the yo is, but but it did. You could write a regular expression that looked for what a license plate is and just do some kind of an assertion on there. But again, what's great about this is I don't have to write this, train a model, and do all this stuff. I can just immediately get to work. So now that we know how this works, let me also, and how to test it, let me show you how Boto 3 works. So I'm going to go to Boto 3 here. And with Boto 3, what's great about Boto 3 is that it's probably the most simple way to do anything in Python with AWS. And in fact, probably even any library, any language, it's the most high-level way. And I can look at every single thing that you can do on AWS is available with Boto 3, like literally every single thing. So, for example, if I go to recognition here, we can go to that. That's the thing I was just playing with. It does all the object and images and everything. We can look at the different available methods, and it's amazing actually how many of them they have. They have all kinds of stuff. So the detect text was one of the things I was using, and I can just look through the documentation here and notice that this is really all you need to do is you can just copy that first part of it and then populate it with the values that you have. So really then I just need to know bucket and name. I think that's all I really need to know. And so I can probably just build this out very easily without even looking at anything I've done in the past. So I'm gonna go ahead and see if I can just throw this in there and just go here and just say this, and notice that the one other thing I'll probably need to do is I'll need to make a client. And so this would be, I would need to uncomment the Boto 3 here like this, and then I would do a client. So I would say Boto 3 dot client, and then the client is just the name of the library that you're calling, the sub library inside of the Amazon SDK. In this case, it would be recognition, like that. And then once you call the main service, then each of the capabilities are available as a method. And so here we go, recognition, and I can just comment this out like this. And then I can also comment out the version. There we go. And then I believe that this closes that bracket, and that closes that bracket. That looks pretty good. Now I just need to swap out the bucket with this bucket that I did before. And then this string with the name with this image. Now in theory, let's look at unexpected indentation. That's weird. Oh yeah, that makes sense. Okay, that looks good. Invalid. Now, do I need a comma there? Is that what that is? Invalid syntax. Photo 3. And what I can do is just look at my old version here, because I'm going to be lazy and look at a previous version I did to just make sure I'm doing this right. So I have a bunch of examples here. So like, I don't know, I think I have detect. Here we go. Let's see how I did it before. So what I did was I did image. I don't know what I'm doing differently, but let's just grab that and throw it in there just because I'm lazy. There we go. Response, but in this case I'll say detect text. And inconsistent use of spaces and tabs. That's always fun. I think I can fix that with black. Let's see, does that fix that? Cannot parse when you mix spaces and tabs. I don't know if this thing has, there's something that you can do where you can code formatting, apply code formatting. Oh, yeah. Some of these tools you can actually, if you've got weird spaces in here, you can actually just get rid of them. So I can just make sure that I don't have tabs and spaces this way. But a lot of times there's actually tools that you can use that will. I usually would just get rid of the tabs and spaces. This is one of the one thing that's kind of irritating about Python, is if you copy and paste code, it gets angry at you. So I should have copied it a different way. So let's go through here. Let's get rid of these. And let's just do this. That looks good. And then let's just make sure that looks good. So in theory, what does this say? Undefined variable name. Oh, because name will be image. And does that work now? And then what is this one? It says, oh, undefined variable recognition. Because I just called this recognition. Recognition equals, there you go. So does this look like it's in theory working? What is that? Unused variable response. Okay, well, we'll return the response. There we go. We'll return response. Okay, so this I think should work. And I could say results, and then I could just say print result. Let's try that. And looks good. So I can say same thing. I could do make lint to just make sure I didn't blow anything up. Okay, in theory this might work, and then I can go through here and say hello object. Now those two things are fake, so it is going to fail because there's nothing in there. So that at least looks promising. That it didn't. I just have I don't have those. Those are invalid bucket names. So what I can do is I'm going to go to the console now, where S3 is, and I'm going to look at a bucket, either create a new bucket or use an existing one. I have so many buckets that I created that a lot of times I have to delete buckets before I can even create a new one. So I'll just do that. I'll just say, put this bucket. I must have created that like 4 years ago. Okay, there we go. We delete this thing. I'm going to create a new bucket, and we'll call this CV demo September. And I'll say next. Just create bucket. And then from here, I can just upload that image inside. So I can just treat it like Dropbox or something. Right? I can just go through here and just upload it by saying add files. And I'll add the this file here. There you go, which is the license plate number. And so then now all I got to do is just take that file name, which I can just copy, and then I could go back to my script here, and just swap those things out. So I know that this should be the name of the image, which would be that we're going to grab the text out of, which is this, and then the bucket name will be this thing, which is CV demo. Go through here and do this like that. Okay, so this might work. Let's try this out. Boom, there you go. So we're able to go through here and extract it out. Now, there's some problems with this approach that I'm going to fix. And the main problem with this approach is it's hard coded. And this is, I think when I see students, especially first starting to build tools, it's fine to build this. I mean, this is okay, but we can do much better. And you know, I mean, by the way, this is pretty good. This is pretty good because we have linting, we have like pretty high quality, we have a function, but we can go better. And I think this is a lot of times, again, as a student, that this is one of the things I see all the time is that students don't write command line tools. And I would say this is critical to learn how to write command line tools because it makes you 10 times more effective. And I'll show you why it's so important. So first though, let's check this code in. Again, we'll double check that this works. So let's just do make lint, make sure everything works. Okay, good. We'll say make format. Now watch, I probably made all kinds of weird formatting errors. Look, this tool will actually fix it. Let's see what it does. Look, see, it did all kinds of changes inside of here. Okay, there we go. So that looks good. So next, what I will do then is I'm going to say get status here again, which I'll make this a little bit higher. Here we go. So we'll say get status and get add hello, adding working computer vision project. Computer vision project. Okay, that is good. So the next step here is going to be, we need to make this more reusable by building a command line tool, because this is hard coded to talk to a bucket and it's hard coded to talk to an image, which is not that useful. I mean, it's okay, but really as a student or as a machine learning engineer, you want to build tools that you can just give to somebody else and they don't need to ask you any questions. They can use it and be productive immediately. And also a year or two from now, you don't want to have to come back to your project and then all of a sudden you run it and you don't know what's happening, right? That's you want it to be very clear that it's extensible and you can make changes to it. So that's what we're going to do next is, so how do we do this? Fortunately, it's pretty easy to turn this into a command line tool with Click. And so I'm going to import that Click framework here. And it really is a miracle tool. And in fact, I almost can remember from the top of my head, but I will try to guess. Let's see if I can guess and see if I can do this all from the top of my head. So if name under is equal to main. So what this thing does is it's an entry point for a command line tool. It just tells your script to run whatever function is in here. So we're going to build another function called CLI. Will be really boring. And so then I can just build something here that is called CLI. And it's just going to take the same thing the function above there takes, right? And so in this case, we'll make it take a bucket and image. And I believe, if I remember correctly, well, first of all, we know that this is essentially what we need to return, is something like that. And this doesn't need to be def. It needs to be literally call the function, which will be the command line tool. So now we just need to add the click stuff here, which the click stuff, I am going to be a little bit lazy because I have an example here. So I'm just going to say copy this stuff here, which is kind of boilerplate code. and we'll go here. And what this does is, and it's pretty cool, is that just by putting @click command on top, it converts whatever the options are into options. And then this is a flag that will be captured from the command line and passed into this function right here. And then it will also give you a prompt as well. It's optional. You don't have to do a prompt, but it can prompt you as well, which again can make it really intuitive for people that use your tool. And then you could say, this is the S3 bucket that contains your image. And then this is the name of your image to be analyzed, like this, right? So I can actually add some helpful messages inside of here. And in fact, we probably would want to say swap these. So this would be like this. Like we could put that as the help, and then for the actually for the prompts, maybe we actually just put in the S3 image object name, and then I could put in the rest of that stuff. I could just do this like, right. So this is kind of clear. This is the name of the image to be analyzed, and then in here even I can actually add like meta documentation. Like I can add the high level documentation. So if I do a triple quote, I can say this is a computer vision CLI that extracts text from an image in S3, and say, to use the tool, do the following. And then you, what do we call this thing? Hello object dash dash bucket foo dash dash name is bar, right? You know, so basically I can build out a pretty neat little documentation here. And so that looks pretty good. And then the other thing that I'll do is that I will swap this out to detect labels so that it is the bucket, and then this will be the name, right? Because this is coming in from the command line tool, and that should make those warnings go away, I believe. Name. Oh, this one says image. So maybe we'll just say image. There we go. That looks good. And then this is just something that's irritating that you get because the command line tool is so fancy. It does all kinds of meta programming that if you want Pylint to work properly, you have to do this. You have to just basically you have to put this like ignore warning, just so it because it does so much magic that the Pylint is not smart enough to understand what's happening. Okay, so once I do this, this looks pretty good. Now the one thing that I will, well let's start with this. Let's start with this, and I'll show you some other fancy stuff. Now I like to keep the function like protected, and I don't modify it because we also could use it for some other tool. We could actually import this as a library, right? Which is pretty neat. I could just import this into another tool. I could build this into a Lambda function. So that's one advantage of not kind of wrapping the function all together in the command line tool, is that I could even move the code into another file or something. But in a nutshell, this thing looks pretty good to go. So let's just run it. So I'm gonna again here and say, what do we call this thing? Hello object, and I'll do dash dash help first. And if you see here, this looks like a professional wrote it, right? It's got, here's my options. You know, this looks like I'm working at Amazon, and I only built it in 10 minutes. You know, this is a computer vision CLI that extracts text from an image in S3 to use the tool, do the following. dot slash hello object. I think, let me change that typo because that's kind of irritating. So look how easy it is to change the documentation. There you go. I fixed that typo. Dash bucket foo. Right. So pretty clear explanation about how to do it. So I'm going to go through here and say bucket, and I think the bucket name was this, and then the name, which I think is name here, would be the name of the file in here, which we have identified as this. Okay, there we go. So got unexpected argument name. So I messed up something here, so I can fix that. So let's fix that. This should be pretty easy. So because this would be, just to make things, it really doesn't matter that much, but to make things easier here, I'm just going to swap this out. I'm going to make this the same and just make this the same. There we go. I think that should work. And do that. I mean, there's a bunch of ways to handle this, but let's just do that. Okay. And now if I run it again, we can go through here. CLI got did I save this? That should work. Got an unexpected argument name. Because that's what I was messing up. This is name, and this is name here. So I actually didn't need to change what I changed before. But anyway, there's a bunch of ways to solve this. Here we go. Get this running. There we go. Got the bucket. Now we don't do anything with it though, right? So how would we print these out and make it a little bit more friendly? And I think before, if we look through here, it printed out a bunch of kind of garbage stuff here that's hard to read. And so what we could do is we could actually extract this. So we could say like, detected text here would be equal to results. So we could take that the dictionary out and clean that up. That looks pretty good. And then we could even look at the type. So we could just say prints type, or print actually we already know what it is. It's a list of other dictionaries. So what we could do is we could just say for detected in detect text, why don't we print out the value for detected text, right? Let's just print those out. And so we could even use some fancy things that this thing has, which is that Click has like a color highlighting. So you can do color highlighting. So we can actually make it a little bit more professional here, and we can see that we could do this. We could say like found text here, and this just kind of adds in like a little found text, and we could say for, and we could put in the name of the bucket, right? So we could kind of make it look a little bit neat here. So for the bucket, and do like a colon or something, and name. What are we doing? Yeah, we're doing name here, and name. That's right. So this will just put in red like, hey, I found some results, and then what I'll do is I'll put it in a different color. Let's see, we can do, exactly like for label in labels, or I can make a background blue, foreground white. So let's go ahead and do that. So we'll just say, click the command line tool itself to I guess to make this a little bit cleaner, I'm going to say, text equals detected, and then I'll put in the key here, which is detected text, like that. And then what I will do is I'll say, give me the text that it found, and then print it out with a background blue, foreground white. So we should have a red that just kind of says, hey, we found some stuff. And then each time I find something, it should just print out the text that it found. And we could actually add, and I could even say my own thing. I could even say found text like this, like that. So I can print that out. So let's see if this works. So we'll do the same thing we did before. We'll run this. And there we go. So it says found text for bucket, right? And actually we should swap this because this needs to be an F string. So to get that fancy formatting, you have to put an F at the beginning like this. Okay, so now let's do it one more time. So there we go. So found text. So anyway, as a first pass, not bad. Not a bad little command line tool, which again, it makes you look very professional that you can build out. And this is only 30 lines of code. And I think this is again is something I've seen many students kind of struggle with. But my opinion, every time you solve a problem, convert it into a command line tool so that you don't have to waste your time abandoning something. If you don't build it into a command line tool, it's almost like you opened up a box to get something from Amazon, just left the box laying in your house. And after a while, you have boxes all over your house and you can't get anywhere. You need to finish the job and take the box, flatten it, put it outside to recycling. This is kind of the same thing. It's just finish it off, build a command line tool that lets you do, things more than what you just did. Okay, so this looks pretty good, but let's actually now use it to do other things. So let's go back to another license plate, right? Or actually, let's type in Michael Jordan. I always like Michael Jordan. So let's see if we can find a picture of him where he's doing something cool and there's text. Let's see this. There we go. There's a 45 and a 23. Let's try that. Or actually, I like this. The GOAT, the greatest of all time. Let's try to do this image, and we'll say MJ GOAT. And let's upload this to this image, to this directory here. And let's go back to this, upload it, go to add files, and do MJ GOAT. Okay, there we go. Upload this. So now we've got a file called MJ GOAT. So it should be really easy. We just, again, now we have a tool that's very powerful now because we just go through here and just type in MJ GOAT. And does it work? There we go. It does work. So we were able to find all this stuff in the image that they gave us. We found Jordan, we found GOAT, we found 24. I'm not sure why I didn't find 23 in there, but anyway, we were able to grab a bunch of text out of that image. Now, if we wanted to get more verbose, we could actually make it, look at the probabilities, because I think if we look here, for example, you could notice that it has confidence. So I guess actually, you know what, if we want to make this a little bit trickier, maybe what we could do is we could look at the confidence and see, as long as the confidence is above 90%, show us the results. Otherwise, just don't print it out, right? Because we don't want to mess around with bad results. So how would we do this? Let's see if we can tweak this a little bit. So let's see, because I think it says detected text, and that is, I think it does put the confidence inside of there. Detected text, yeah, it puts confidence. Yeah, so we can easily change this. So we can just say, basically, confidence. Let's just say, we'll say if. So that's the text, and we say if the. So it's detected text. Yeah, if detected confidence is greater than 0.90, then do this. So let's see what this does. We'll say text. So let's see if we can make it a little bit more strict, like our own tool. And we could, by the way, we could add this and change this into flags or do whatever. So if we go through here, let's see. So it looks like it's less. It definitely looks like it had less. But what happens if we change it to 0.99? Let's see. Actually, maybe that's an option I could add to the command line tool. I don't know if that's working actually, or maybe it is. And what we could do is we could say we could print out the length here, len of detected. Let's just see what happens. So how many results did it find? So it found 656. Interesting. Well, yeah, without getting without getting into too much craziness, I could I could go in here and just keep adding more and more flags. Depending on what it is I want to solve. But let's just say that that's what I want to build is this thing. So let's go ahead and check the lengths. That looks good. Check the format. That looks good. And commit this, adding label detect, text detection CLI. So git add. There we go. Okay. So this is pretty awesome, again, because of the fact that I can use it and easily extend it, and I could use this space that I built today for the next 5 years, and again show it to other people or whatever. I mean, I could even put this into the Python standard library, or I'm sorry, the Python packaging repository, right? And other people that had AWS accounts could use my code because there's nothing hard coded. This is all generic code, and that's the other thing too is typically when you hard code things into your example, that's when things get a little bit brittle. And so what I can do next here is take it to the next level and actually show you how we could hook this up into a Lambda function. And that'll probably be the last thing that we'll cover. So I'm going to show you inside of AWS, they have this thing called Lambda. And what's awesome about it is that it's very similar to what we just did, except for it runs inside of the cloud. And so here's an example of, I say, test Lambda September or something like that. I can change this runtime to, let's do Python 3.6, and let's go ahead and create a function. But I'm going to do a role here because I know I'm going to do some administrative functions like S3. So I'm going to say use an existing role, and this one will be has like demo privileges. So this one thing to keep in mind is if you do want to do something with Lambda that in your demoing, you need to give it an IAM role that has the privileges to test whatever it is you're doing. To start with, though, look, it's pretty simple. It's just like we were doing before. It's just a function, right? So I can just go through here and just say, like the one I always like to build is Marco Polo, right? So I go through here and just build out, and I can say, if event Marco name is equal to Marco return Polo. There you go. Otherwise, return back no. Right? So there we go. Got this. I'm going to create a test event, which is a way to test an object that I put inside of there. We'll call this one Marco. So the whole idea is this again is just a function. So I'll go through here and I'll say name Marco like that. And there we go. Create it, test it, and there we go. We see that it looks like, oh, I didn't save it. Let's test it. There you go. So it says Polo, right? It says returns back Polo. And if I give it a different name, and I just say another test event, and we'll call this one Bob. Let's just call this one Bob. And create it. There we go. No, right? So very, very simple, right? The concept of a Lambda. But here's where it ties into what we were doing before with computer vision is I can tell this thing to listen to a bucket. And every time I put an image into the bucket, it can do what we just did. And so this is, again, why it's nice to have a function that is fairly abstract. And so the command line tool could kind of test out the idea. So how would I do this? Let's just tweak this. So let's actually go to this designer. And a trigger is, again, a lot like a light in your house, like a garage light. It can turn on when you push the garage door, or you can flip the switch on, or it can turn on at night. And so in this case, we're going to add a trigger. And again, there's tons of things you can add triggers on. We're going to add a trigger for S3 right there. And then we're going to go to the bucket that we were messing around with, which was called CV something, or there we go, CV demo. And what it'll do is it'll listen to every time I create a new object inside of this bucket, and it'll run some code. And so I'm going to go ahead and say, yes, enable a trigger. That's great. I acknowledge that I have a trigger. Okay, so now that I got this, I have some code that I'm going to reuse that for ease of use, I'll use some of it. So let's see here. I think I have Lambda example detects. No, it's going to be S3 trigger Lambda. So let me just throw this in there first into here. So I'm going to go to this function, and I'm going to put this code at the beginning like this, and it imports Boto 3. All this does here is that, remember that every time I put a file into S3, an event is generated. And we saw what the event looks like. It's just some thing that's got some information in it. When it listens to S3, it has this stuff in it. It has the stuff you would expect, right? Which is what we were just dealing with, which is the S3 object and the bucket. It comes in the payload. And so we just grab that payload. That's all we do. And so we just know where the bucket is and where the image name is, which is exactly what we need to do computer vision. So now that I got that, I can go to the next section, which is this Lambda handler. And so I could use the old code that I built earlier, or I could just use this code. I mean, it doesn't really matter. Just for fun, I guess. Let's try to let's try to use the code I did before, which was let's get rid of this. And I think so this Lambda handler, it will print out that it found the events, look for all the events in the bucket, and then this is really the thing that does all the work. It is the label. Now, in this particular example, though, I don't want to detect the label. I want to detect the text. So I'm going to go back to my function here, and I'm going to find that function that I wrote earlier. I'm just going to copy it. And now, if I was using a library or I had a structure out, I could make this a little bit more extensible. But just for a demo purpose, I'm just going to throw this in here like this, right? And we know that this is what we just were using, right? It's called detect label. And all I have to do is just swap this out, take this code out here, and in fact, just swap it and just say, what do we want here? We want detect labels like that. Actually, it's pretty close. It'll just be this. We can get rid of this. This is the image name. There we go. Detect. But in this case, this will be the. And I said I found this. I'll just say I found this text. Just like that. And this will be the results. And then I think the way we did it before was we wanted to get the this thing the detected text out. So we'll just put that here. We'll just say results is equal to detected text or something like that. So I think that should work, right? So it basically goes through, grabs the text, and so all this will do is use the function we built earlier, which we already tested with the command line tool. All this does is it just listens to the event and grabs the stuff out of the event, and then this is the handler that gets called when the function gets called automatically when I put an image in there. So I think in theory, let's label function, detect labels. This probably will work, but let's test it out. So how do I test it out? This is where it gets a little bit more complex, is I need to put an image inside of there. And so I just need to go back to the S3 environment. So I need to go to, let's see here. Let's go to console, go back to S3 and find the bucket. Computer vision demo September. Just for laziness, I'm going to upload this again because I just want to trigger it again. And so we'll go there, we'll trigger it. And in theory, this should immediately run this. And so how would I know? I could go to monitoring and look at the logs. And my suspicion is I have an error somewhere because it's easy to make a mistake. But let's see. Maybe I got lucky. Yeah, okay, there we go. Syntax error, which is expected. So what is that syntax error? Invalid line 22. So let's see this. Go back to this function. Find the mistake here on line 22. Print. Oh, well, let's not get too tricky here. Let's just print out the result. How about that? Let's just make anything work. So I'm going to save that, and then I'm going to go again to that bucket, and I'm going to upload something again. Let's add the license plate here. Okay, so upload it. I don't know what it does when you have more than one of the same thing. What does it do? Huh, maybe it actually doesn't like it when you, so I'll just find a different image. Here we go, Michael Jordan. There's another one. We'll call this one MJ. Throw this up there, upload it, upload MJ. There we go. And next. Or maybe I just was never uploading it. Okay, so we've got that. That's uploaded. And I'm going to go back to my function, look at the monitoring, and we should have some logs in here that show us that things are successful. Oh, expected an indented block, line 26. That's what I get for building this in a console. It's really easy to make an indentation mistake. So what is it? Oh, that makes sense. Oh, that's weird. Yeah, so I accidentally put the function definition to the left there. So let's go this. We'll again upload another file here. Hopefully that'll let me do the same file multiple times. Does it let me do that? Well, let's do this. Let's just delete these files and let's upload a new file. There we go. Okay, so we got a new file that should have triggered it. I can go back to monitoring. So you can see it's a little bit trickier when you use something like a Lambda, because there's a lot of back and forth because it's running. There we go. So we see MJ goat. It found this. Now it said I found this text, so it did find all this text and did have an error. It said name labels is not defined, which on line 36. So I need to fix that final bug here, which I must have put a mistake here. Yeah, so I think labels is not defined. Label function. Label function. Well, it's definitely seems like it's.
Because you're returning labels.
Oh, I'm returning. Oh, I see. I'm returning. Oh, good point. Yeah, so yeah, you're right. It works, but I should be returning back results like that. Good call. There we go. So I'll try one more time. See if we can get a perfect fit here. We can delete actions. Delete this. Why is this not letting me delete? Properties. This user interface is not the best. Action. There we go. Delete. We'll put the license up there. Upload. Add the license. There we go. So it worked. It just it was working on the wrong thing. So if I go back again to this last section, we can look at this, and hopefully get a perfect score. There we go. License. I found this text. There we go. Everything's happy. So still not bad to be able to build like a trigger based function here that we also have a command line tool. So what I'll do is I'll take this function here and I will just copy it all, just go like this. And I could actually, if I wanted to, do all kinds of tricky stuff, but I'm just going to go to the Git repo here, and I'm just going to add this as an example for other people. I'm just going to say create new file and just say lambda trigger example .py. There we go. Other people can play around with this. Lambda trigger. There we go. All right. So yeah, that's probably a good stopping point